Okay, so this is part 2 of our stretches lesson. This is horizontal stretches. So you'll see at the top here, we've written trig. Remember, this is going to be either sine or cos, depending on the question. And then we have our k value before our angle, before our theta or x or whatever letter we use there. Okay, so k value is the horizontal stretch, which you know from all of our other transformations. Okay, so the one thing to remember about k is that whatever value it says, we actually have to use 1 over that value in our graphing. Okay, so that's true for quadratics, roots, rationals, and also sine and cos functions. So what we want to do is we want to take our key points and we want to multiply all of our key points x values by 1 over 3. Okay, so here's my 5 key points for my sine function, and I'm using my sine function because in the question it's sine. So what we want to do is we want to multiply all of our x values by 1/3. So in our new points, okay, 0 divided by 3 is 0, so this point's going to stay 0. Okay, we're going to do 90 divided by 3, 180 divided by 3, 270 divided by 3, and 360 divided by 3. Okay, so what we've done is we've taken all of our x values and we've divided them by 3. Or you could say we've multiplied them by 1/3, right? So we'll multiply them by 1/3. Same thing, same result. So our new key points are 0, 0, 31, 60, 0, 90, -1, and 120, 0. So what that means when I graph a sketch here, okay, I'm still starting at 0, 0. But what's changed is my point. So instead of my final point being over here at 360, it's now at 120. Okay, so this is just a rough sketch. We're not changing our amplitude. Our amplitude is still 1. Our max is still 1. Our minimum is still -1. Okay, all that's changing is our key point. So I'm at 0, 0, 60, 0, and 120, 0. Okay, so if I'm going to state the period for this cycle, or for this graph, I have to look at how long one cycle is. So you can see that one cycle only takes 120 degrees now, instead of 360 degrees. But our amplitude has remained at 1. Okay, and if we want to state the domain and range for one cycle, our x values are between 0 and 120. And our y values are between -1 and 1. Okay, so we'll do a couple of notes on this and then we'll do some more examples. Okay, so same thing, but now we have a k value of 1/2 right here. So when we actually graph this, what we're going to do is we're going to multiply everything by 2, because we have to flip it. So instead of 1 over 2, now it's 2. So I'm taking all of my key points and then multiplying them by 2. Okay, so there's my key points, my x's and my y's, and I'm multiplying all of my y values by 2. So I'm just writing this in a different format so that we can see both ways. So what happens is 0 times 2 is 0. Okay, 90 times 2 is 180. 180 times 2 is 360. Okay, 270 times 2 is 540, and 360 times 2 is 720. So what we've done is we've multiplied all of our x values by 2, and now we can sketch a graph. Okay, so now we can sketch a graph. So our shape is staying the same, okay, but what we're doing now is we're starting at 0, 0. Our middle value is at 360, and we're going all the way over to 720. Okay, so the shape of my graph hasn't changed. My maximum is still 1. My minimum is still negative 1. The only thing that's changed is that instead of ending at 360, now my graph goes all the way to 720. Okay, so when we're talking about the period, one cycle takes 720 degrees instead of our usual 360. My amplitude hasn't changed, and my domain is now all the way from 0 to 720. 720 degrees. But my range has remained the same as the base graph. Okay? So the range is between negative 1 and 1. That hasn't changed. My maximum and minimum are the same. So what we'll do is we'll just go through this as a note. Okay? So horizontal stretches. What is affected by horizontal stretches? It's the period. So vertical stretches, the amplitude is affected. Horizontal stretches, the period is affected. Okay? And what happens is our period changes based on our k value. So you'll notice here we have an example. So for our sine x, our period is 360. That's our base graph. Whereas if I put a number in front of the x, what happens is I take my period and I have to divide it by k. Okay? So if I take 360 and divide it by my k value, that will tell us our period. So for example, okay, in our first question, we had y equals sine 3x. So if I take my value 3, my k value, and I do 360 divided by 3, my period is 120. Okay, and if you look back, that's what we discovered when we did it using mapping notation. Okay, so when k is greater than 1, you end up getting a smaller period, a shorter period. When k is between 0 and 1, so like in the second example where k was half, what happens is we do 360 divided by a half, which ends up being 720. So when your k value is a fraction, you actually end up with a larger period. Okay, so we'll just do one example for this. Okay, determine the period for each of the following. So we want to take 360 and divide it by our k value. So in this question, k is 1 over 4. So we'll do 360 divided by 1 over 4, okay, which is the same as 360 times 4. Okay, so the period for this equation would be 1,440. In the second equation here, we have an a value of 5 and a k value of 3. So the only one that affects the period is the k. So our k value is 3. So our period is 360 divided by k. So 360 divided by 3, which is 120.